I'm Chris Savage, and this is Savage Circuits TV. This episode of Savage Circuits TV was brought to you by Sony Creative Software. Visit them on the web at sonycreativesoftware.com. Welcome to episode 3 of Savage Circuits TV. In this episode, we'll be talking about how you can build the Garage Parking Assistant. Now this project was featured on the front cover of Nuts and Bolts magazine, January of 2010. And if you go pick this up at your local newsstand or happen to be lucky enough to subscribe to it, you can find the complete article inside. If not, we're going to tell you how you can go ahead and build one anyway. If you don't have a subscription to Nuts and Bolts magazine, you can get one by going to their website at www.nutsvolts.com. This project was inspired by a similar project by Rusty Turley, which was posted on the Parallax support and discussion forums. When my wife and I moved into a house with a 2-car garage, it became clear that we needed a solution to parking both vehicles inside the garage and still having room to move around. As you can see, with both cars parked in the garage, there's very little room on either side. There's also a lack of space in the back of the garage where we need to be able to walk around. In order for my wife and I to be able to park in the garage and to get in and out of our vehicles, I have to back my car in on the right side while she pulls in on the left. Ideally, she needs to leave enough room to walk in front of the car, but also to be able to get into the trunk, if need be, without opening the garage door. That is the tricky part. The Garage Parking Assistant takes the guesswork out of how far ahead to pull in. As anyone who drives a car is familiar with traffic lights, the display was modeled around them. 10mm LEDs were used for the indicators, as they're easier to see. A green LED means go, a yellow means slow down, and red means stop. If the car moves past the red stop zone, the red LED blinks to indicate this. The main controller and LEDs are mounted at eye level to the vehicle, while the ultrasonic sensor is mounted even with the license plate and front bumper to ensure good reflection. The range of the sensor is split into 4 zones corresponding to the 4 states of the LEDs. The maximum range of the sensor is about 10 feet, and the furthest zone is zone 4. To set up the zones, you simply hold the button on the front until the LED is all flashed 3 times. At this point, the Garage Parking Assistant wants to know where the green zone starts. So the green LED will start blinking. For most applications, this will be the maximum range, so with nothing in front of the sensor, you can simply hit the button to store that value. At this point, the yellow LED starts blinking, and you should pull the vehicle into the point where you'd want to slow down. Once you press the button to set the yellow zone, the red LED will start blinking, and you should pull the vehicle into the optimal stopping position and press the button. The Garage Parking Assistant will now store and use the new distances for the 4 zones. It's important when you're pressing the button not to be in front of the sensor or anywhere in its field of view, as this could cause errors in the stored value. For complete project information, including pictures, schematics, and source code, please visit the project page on our website at savagecircuits.com/Garage Parking Assistant. You'll also find a link on the project page for discussion of this project on our forums. Okay, now let's get into building your own Garage Parking Assistant. First I'll cover what I did to build mine, and then you can make adjustments and changes as you see fit for yours. First I'll cover the enclosures I used in the design. The one that you see right now is a small plastic enclosure purchased from Radio Shack. It's got a plastic case with a metal top on it. I believe they actually have some of these that have a plastic top as well if it's easier for you to cut the plastic instead of the metal. And I mounted the ping so that it was kind of recessed back behind the panel by using some 1/4-inch nylon spacers. And you'll notice the nylon washers behind the ping as well. That's because if you just tighten the nuts down on top of the ping sensor, you'll actually cut into traces and cause a short. So that's a little tip. You want to keep nylon in front and behind the ping when you're mounting it, no matter what you're mounting it to. Now the entire assembly fit neatly inside this little project enclosure, which I mounted using sheetrock screws to the garage wall at the height of the license plate and front bumper. So here's what the sensor looks like mounted to the wall. Now the enclosure for the main board I chose was a PackTech enclosure that's actually designed to be sealed. It actually has a rubber gasket between the front and the back. But what I liked was the side tabs that made it easy to mount to the wall. Super carrier board is usually my choice of basic stamp related projects for making them permanent, putting them in an enclosure. It's inexpensive, has the solder holes on it, good for one-off projects. So what I did was I mounted standoffs inside the enclosure at the spacing for the holes in the super carrier board, and then I lined up where the LEDs were going to be with the front of the case and drilled those holes. Now there's no facility for reprogramming this once it's inside the enclosure, so you really have to make sure that you have everything set before you seal it up. The other neat thing about the enclosure here is that since the screws mount the face to the enclosure from the back, those side tabs allow you to still mount the enclosure to the wall after that's been done, unlike the enclosure for the sensor where I was able to put the screws inside and then screw the front panel on. Now the project enclosure itself was mounted at the height of the windshield in the car so that it's good for line of sight. When you're pulling in, you can actually see the three 10mm LEDs. Here's a picture of it on a garage wall with the car pulled in. Just happened to be a convenient outlet right there to plug the whole system right into. Just a few notes on the super carrier board used. You'll want to look at the high-res photographs on the website to see exactly where the connections are made, because I used very specific I/O pins in this system for the LEDs to be spaced so they're not consecutive. Plus the switch was added later, the push button switch for setting the distances, so that was kind of an afterthought in the design. It was added to make it so that you could set your distances without having a laptop connected, because that's how I originally calibrated this unit. Now, one or two of our employees and several of the forum users from the Parallax forums have gone and made their own versions of this, and you can make your own version as well. It doesn't have to be the same case, the enclosure doesn't even have to be the super carrier board. It doesn't really have to look exactly like this. I had somebody write me in from the article an email asking he could hook a traffic light up. An actual full-scale traffic light that he had won on an auction. And yes, you could do that. The outputs that would normally drive the LEDs are going to drive solid-state relays instead, the LEDs inside those, which will then in turn drive the traffic light. Or there's several other ways you could do it, but the point is you can easily customize this and tailor it to your application. You can also customize the code. For example, one person who emailed me asked if he could add an alarm so that when you pull too far ahead, instead of the LED flashing, it plays a warning tone. Easy to do. I'm Chris Savage, and we'll see you next time. So